It's a good question. I guess they might just practice indoors, I guess. I'm not sure what they were practicing for.
Maybe Friday. Or
possibly. It wasn't, I don't think it was just the game. It was something else. But S of 2 equals 15. Make sure you label it S of 2. And so, now we need to talk about what that means. So, first of all, our T, which is on our x-axis, what does it equal? Time. So, when time is 2 hours, so this is your x. Right here, 2 is your x. So, at 2 hours, and then we're just plugging straight into this equation. What does the equation tell us? What is the distance the car is from the given gas station? So, what do we know at 2 hours?
The car is 15 miles from the gas station.
The car is 15 miles from the gas station. This is really not calculus right there.
Well, understanding how to do that is too much.
Yeah, I could make kids do this in Math 1, but it probably wouldn't go well, so. Alright. But B, what does B ask us for? Okay, so first thing we got to find if we want S prime of T is the derivative of S of T, but you don't know how to take the derivative of S of T as it is right now. So you need to expand it. You do.
Oh, is it whenever we got
We're just going to multiply it out. Yeah. So, you could go ahead and distribute the 5 to this T plus 1 if you want. And then T minus 3 squared is T squared minus 6T plus 9. And then you must distribute. Oh, yes, thank you. Alright, so we have 5T cubed minus 30T plus 45T squared. Yes, thank you. And then we do 5T squared. I like putting it right here. Yeah, T's are bad variables. You got to make a curvy T. Yeah, that's the secret to it. Minus 30T plus 45. And we'll add those together. So S of T is 5T cubed. I'm trying to write big for Alfredo. 25T squared plus 15T plus 45. What you got to be careful of here is you have not yet found the derivative, right? We have just expanded, so now we have to find the derivative. So S prime of T is going to give us 15T squared minus 50T plus 15. Okay, here.
That's the end of part B.
It's not the end of part B because what did they ask us for in B?
Oh, we got to put 2 in.
We got to put 2 in. S prime of 2. 15 times 2 squared minus 50 times 2 plus 15. You do want to go ahead and get a number here because you're going to have a hard time explaining that if you don't have a number for this, right? So it's going to be 15 times 4 minus 100 plus 15. So 60 minus 100 plus 15. I believe you're going to get negative 25. So, if we think about the derivative is the slope. So I drew this up here. So if we're finding slope, slope is your change in y over your change in x, which for this particular graph would be change in miles over change in hours, which is miles per hour, which we use to measure what? Let's go with velocity. Is not the same thing. Because, what's the difference between speed and velocity? Alright, some of my physics kids tell me about velocity. Yeah. Velocity has direction and magnitude. Speed is only the magnitude, only how fast you're going. So the positive or negative is your direction with this. So
Despicable Me, whenever the boy says that you got direction and magnitude,
I have not. I've seen that one, but I didn't catch that. That's good. All right, so we start the same way at 2 hours because we're still looking at 2, right? So what would we say about the car? All right, so the velocity, I'm okay with just saying the velocity of the car is negative 25 miles per hour. That's okay with me. Or you can say 25 miles per hour in the negative direction. Fine, also. When we're talking about velocity, in this case, he's on a straight road. So the gas station is like your 0 right here, because he would be at the gas station at 0. So if you're going to the right, that would be your positive velocity, and if you're going to the left, that would be your negative velocity. So he is traveling to the left. If you were like looking at this straight road. All right, so for C, all right, C, actually, I'm sorry. You're right, Thomas. What do we, all right, we don't plug in 0, but is there ever a time on the interval from 0 to 4 at which the car reaches the gas station? If so, find the time that this happens.
0 equals 15t squared minus 50t equals 15.
All right, 15t squared plus minus 50 plus 15 is our derivative, which is our velocity.
We want 5t to the third minus 25t squared.
Yeah, I didn't have it written out. Yeah, this.
Yeah, you got it
right here. We want the original equation because that tells us the distance from the gas station, right? And we want that distance from the gas station to be 0 because if it is 0, you're at the gas station, right? So we take the original function, 5 times t plus 1, t minus 3 squared equals 0. Thankfully, they said we are setting this equal to 0. So that's already factored for you. So you set each thing equal to 0. 5 equals 0, but you don't get anything from that. T plus 1 equals 0, so you just get t equals negative 1. And t minus 3 squared equals 0, which is just going to give you t equals 3. No. The ant is not plus or minus 3 because you would square root both sides first, which would give you t minus 3 equals, I mean, if you want to put the plus or minus with a 0, you can, but there is no positive or negative 0. So, if it was t squared minus 3, then we would have to have a plus or minus there. So, we need to throw one of these out. Which one? The negative, because they told us that t is greater than or equal to 0 at the beginning. So, we are going to say right here at 3 hours. And you can just circle that as your answer. Yeah. You have to know what it's looking for.
So we don't have to, like, explain it.
You do not have to explain it. You have to show your work.
Yeah.
Like on this, on the rubric for this one, you get a point for setting the function equal to 0, and then a point for getting the correct answer. So if you don't write down where you set these equal to each other, you won't get that point. Did you hear that, Daniel?
Okay.
If you do not write this, there's 2 points on the rubric for this. 1 point is for setting the function equal to 0. If you don't do that, which I have a feeling you wouldn't, because you would just think, oh, it's equal to 0, so it's got to be -1 and 3, because you're doing that part in your head, then you would not get that point. So you have to show where you write it down. I know exactly what you would do, which is why I'm calling you out and telling you not to do that. You have to write this down, or you don't get both points on that problem. All right, what do you guys think we should do? Is there ever a time on the interval from 0 to 4 at which the car stops?
This cannot be determined by the information given.
It can be determined. All right, if you stop,
Your speed is 0.
your velocity is 0.
So you find the derivative of 0.
So if my derivative, which is my velocity, equals 0, then I have stopped. So I can take the velocity, which was up here, 15t squared minus 50t, is it plus 15? I'm going to set that velocity equal to 0, because if I have stopped, my velocity is 0. And this is just a quadratic. I'm going to divide everything by 5 so that I don't have to deal with the 5, the bigger number. So I got 3t squared minus 10t plus 3 equals 0. So you got 3t and t. You need a minus 3 right here and a plus. I'm sorry, minus, they're both minus. Minus 1 right here. And that will work because you're getting a -1t for those inner terms and a -9t for the outer, which is going to give you -10t in the middle. Yeah, you kind of got to guess and check until you get them in the right spot where the inner and the outer terms.
Have you figured out how to factor them?
Yeah, if you switch where they're at, yeah, you won't get. No, it does not. It does if you have like a t and a t. But when you have a coefficient in front of your t, it does not. So you have to sort of guess and check. All right, so you got 3t minus 1 equals 0, and t minus 3 equals 0. So this is going to be 3t equals 1.
Instead of like separating them,
while they're still equal to 0 after the factor, can we like do the t equals, like, because that would be 1/3, right?
Yes.
So,
Like, you mean do it in your head without writing it down? Yeah, that's fine. I usually try to write it down just to make sure everybody's following me where it comes from, but you can go straight.
That's understandable.
No.
So, on this one, there's a point for setting these equal to each other. Then there is a point for getting both of these answers. So, if you don't write this first step down, you're not going to get that point. So, you need to make sure you write the equals. That's fine, same thing. Yeah. And you really could just factor it without factoring out a greatest common factor, and you'll still get the same answers. So the car stops at 1/3 and at 3. Yes. I mean, really, we probably should put hours here, but you do not have to. I guess it should be hour, not S, right? 1/3 of an hour.
I just put collective hours. Okay. I'm not feeling
Let's go from 1/3
about this.
Okay. All right. Questions?
I have a chance.
Okay.
So are they?
It will either be number 1 or it will be number 2 tomorrow. So I'm not going to give you like 1A and 2C and yeah, because it's confusing to. There may be sometimes I do that, like if I give you pieces of problems instead of giving you a whole problem. But if it's a week where I've given you entire problems, then I will pick the entire problem.
So it'll either be 1A and B or 2A, B, C, D.
Yes.
So both of those points are right.
Yes, both of them are correct. Yeah. It's possible sometimes, like maybe one of them doesn't fit on the interval, so you throw it out like we did with the first part. It tells you that it's between 0 and 4.
Yeah.
So, like for part C, we threw out -1 because it doesn't fall between 0 and 4. Okay. All right.
So that's basically it. Like there's no reason we should.
Except for I'm not taking them right now.
So tomorrow we literally just turn in what we did in class yesterday and today.
Yeah, I mean, I didn't go over part B, so make sure you got that
Oh,
right.
okay.
But yeah. Let's see. Yeah, you want to make sure you know how to do it.
And
We're still in unit
and
2.
you said that on the FRQ it could be limits like horizontal asymptotes and everything, right?
It could be anything. Okay. Product rule. No, you're going to copy these down on your own paper. All right. This is on your own paper. These are notes, but do them on your own paper. Let's see. Let me enlarge this a little bit for Alfredo. I'm also recording Alfredo if you need to look back because. Well, we only got 15 minutes, so it's not going to be that long.
We could share. Oh my god. I'll do the front, you do the back.
We'll split it in half.
Yeah.
What's G? Jack, why are you confused? How are you confused?
Okay.
All right. It's two functions multiplied together.
No way you say product.
Product rule, yes.
I'm gonna use my phone as like a
Oh, I can't make it any bigger. Yeah, here we go.
microscope. No, what do they call it?
I could give Alfredo a clipboard and just let him stand right next to the screen.
I can use my phone again.
Yeah, that's fine. You really need those glasses, don't you?
Yeah.
Are you going to be able to get another pair quick?
I
I'm so too. Do you have a pair of old ones anywhere?
No.
Yeah.
Yeah.
Have you had an eye exam in the last year? Oh, that's the problem. And getting an eye exam is so hard. Yeah. They won't give you new glasses unless you've had them. All right.
Well, it was like 2015 for a while. I used to be farsighted, now it's 2013.
All right. Okay, let's talk about product rule. Okay, there are some types of problems that I've told you so far we could not do because they require to know some different rules, because the only thing we know so far is the power rule. I say product rule instead of power rule often because they just sound too much alike.
We got a 50 on that jump. I'm not sure that we do.
We know how to do the simple ones, right? Maybe.
Yes,
okay. All right. So product rule. Product rule we are going to use when we have two functions that are multiplied together. So two pieces of things that involve x's that are multiplied together.
Would be like an f of g. No.
No.
An f of g of x.
No, there's a different rule for that. I'll show you what it looks like here in a second. So if you have two functions, there's f of x and there is g of x. What you are going to want to do is just take the derivative of f and the derivative of g and put them next to each other. You cannot do that. You have to use the product rule, which tells us that you do f of x times g prime of x plus g of x times f prime of x. So let's look at it. Let's look at the problems you'll be doing. All right, let's do a problem. You guys are panicking again over some you haven't even been taught how to do.
I can't see.
All right. Okay, good. I'm proud of you, Tom. Yeah. All right. Okay. So I've got x squared times cosine x. So you will probably get off those phones. Y'all aren't even paying attention. All right. All right. So you will be tempted to say the derivative of x squared, don't write this down, is 2x. Derivative of cosine is negative sine x. Therefore, the answer is negative 2x sine x. This is wrong. Okay? If you have two things that are multiplied and they both have x's, and you can't combine them because we cannot combine x squared and cosine x. X squared is our f of x. Cosine x is our g of x. So when we take the derivative here, we are going to have just f of x, which is x squared. We don't take the derivative, we just write it down. We are going to multiply it by the derivative of cosine x. So that is going to be negative sine x. We put a plus sign in between. Then we have to just write down g of x. So we just write down cosine of x. And we multiply it by f prime of x, which is 2x. And then after that, you want to clean it up a little bit if you can. There's not much you can do to this one. I'm going to make it negative x squared sine x plus, we typically write this 2x out front, 2x cosine x. This is our derivative.
You know what? It's not that bad. Is it gonna get better?
The hardest thing about this is recognizing that you've got to use the power rule and not just taking the derivative of each one separately.
No, this isn't bad.
One, two things. All right, I got 7 questions at once. Laura, what was your question? Yes. Right. Other questions? Yes.
So, how do you know what to bring out in the front of the final derivative? I got this before that.
Typically, we just write anything with variables in front of our trig functions. So, I mean, technically, it's right here. It's just a little messy.
Yeah.
Yeah.
So you got it.
Okay? All right. Here's another one.
Wait, I do have one quick question.
Yes.
Is dy over dx the same thing as d over dx? Like when you write it in front of the thing?
A little bit. This means take the derivative of this stuff.
Okay.
Yeah. This one's just written where it doesn't have a y equals, so it's a little tiny bit different, but it means take the derivative. Okay. All right, so you do have the option on this to just multiply those two together and then take the derivative, which actually might be easier here, but we're working on product rule, so let's use the product rule, okay? So I've got two things that are multiplied together. Both expressions have x's in them, so this means product rule must be used. No, it's just they're just two parentheses beside each other. Yeah.
In the first parenthesis.
Oh yes, that's negative. It does not matter which one's which. So they're interchangeable here. So if you decide you want to do 5 plus 4x first, it's fine. I usually don't, but you could. So you're going to have 3x minus 2x squared times the derivative of 5 plus 4x, which is 4, plus sign goes in between. The second one, which is 5 plus 4x, times the derivative, 3 minus 4x. So this is our derivative, but it's probably going to be expanded. So we would distribute our 4. So we get 12x minus 8x squared plus, we got to distribute here, 15 minus 20x plus 12x minus 16x squared. And so you got negative 24x squared plus 4x plus 15, I believe. Did I do it right? And so this is your derivative. Now, it might be easier to multiply them together at the beginning and just take the derivative from there, which is an option. You can do that. So we could not on the last one because it was a cosine and there's just nothing that we could do there. So if it's an expression like this, you could just expand and then take the derivative using the power rule. But I just want to practice with some products here. There's also going to be something else we're going to do where when we learn the chain rule, there's going to be a time where we definitely need to use that, but we can't. We haven't seen that yet. Say it again. No, that would be wrong. You cannot take the derivative of them separately. So this is the last one we're going to do real quick. So, do we have to use the product rule for the first part? Do we have to use the product rule for the second part? No, because you do have two things multiplied here, but there's no x with that 2. So it's just a coefficient, so you don't have to use product rule on the second part. But on the first part, you've got a 3x and a sine x that are multiplied together. So you have to use the product rule here. So when you take the derivative, you would have 3x times derivative of sine x, which is cosine x, plus sine x times the derivative of 3x, which is 3. So all of that right there is the derivative of this part. But we still have to take the derivative of minus 2 sine x, which is, minus 2 cosine x. And so again, there's not much you can do with that. You would probably, you got 3x cosine x, you would probably write this 3 out front, so plus 3 sine x minus 2 cosine x. There's not anything you can combine there. Even these cosines, this one has an x right here and this one doesn't, so you would just leave it. Okay. All right. Let me check real quick and see if we can still do all these because I'm not sure about. Let's see, 154. You should be fine on 1 through 6. 13's fine. 17's fine. 19's alright. We did not get to the tangent line ones, but 69 and 70 are tangent line ones. But it's the same thing as we've done for all tangent line ones. You just got to use the power rule to take your derivative. So find this point, find the slope, use the equation. So you should be able to do